Okay, now that you learned about the Electro server and essentially the contents of the socket server that we will be using, the kind of concepts that are either general to socket servers for multiplayer games and virtual worlds, as well as the ones that are unique to the Electro server, such as the Electro server objects. And also you learn about different extensions and plugins uh, and event handlers that you will be using in your Electro server, and also that you installed your Electro server 4.0.6 as well as the Flash Develop IDE, which will install the Adobe's Air Flex Builder compiler and your runtime machines and installations. I would like to show you where you can find the source code at this point for your projects, and then we'll get into the API that we have, and then we start writing the Hello World example. So first off, where can you find the information and the code files for your projects? If you open up your course homepage, Gaming Network Architecture, the Fundamentals of Game Networks, you would go to the Resources tab. That's the tab that you downloaded and installed your Electro server and your Flash Develop IDE. Now, at the bottom of the page, there's a folder called Gamebook Programs. You will be able to find the code, or essentially the backbone code of the projects that you will be working with in this class under this folder. So if you click on the Gamebook Programs, this week you will see Unit 5, Chapter 4 code. So the code is essentially placed under this location, and you would have to download the Hello World example code. It's a compressed zip file, and basically what you need to do is to uncompress it, and it's basically the backbone of the code, so it should be very empty, and you should be following this video to fill up the code, and essentially the textbook also will help you with setting up the code. If you don't have the textbook, you should be okay. I will explain all of the steps that you would have to take to be able to finish up this project. So once your project is set up and copied to your folder, destination folder, where you have the content of this class, you will be able to open it. So when you open the Hello World file, you would see a essentially the Chapter 4 folder, which has the project Hello World in it. Now I have the finished product, and I will show you what this project, what this program does, and then we go through step by step, learning about our IDE, learning about our development platform, and then we work our way through setting up a very simple example of building a client-side code that connects to our Electro server, socket server, and logs in. So if you double click on the project folder, the project folder will be opened in your Flash Develop environment. In the Flash Develop environment, your project will have three main categories, or three main folders with it. The binary files that are related to your project are going to be are placed under the bin folder. The library, which is your ASP or your Active Action Script 3 client-side code for the Electro server 4.0.6, is placed under the libraries. Notice that this library is where the API for your Electro server is installed. I will talk about your Electro server API a little bit later, but the SWC file is basically that API that you'll be using. Under the source, you would have a set of folders with the Hello World folder at the bottom, and the code, which is main.actionscript, main.as file, is where your project is located. I'll just show you a little bit of an overview of this. Basically, this is a class that's basically your Hello World class. It imports the Flash flash.display.sprite and flash.text-to-text fields, and a bunch of Electro server components, such as the Electro server, the entities protocols, message events, message types, message requests, and message responses. We will talk about these a little bit later. And of course, the author of the book is the person who wrote this class. You will have a class which basically extends the class sprite of your Flash environment. A Electro server object is basically created. And with your Electro server object, as you see here, as being instantiated, 3 events are being added to it. I'll talk about these a little bit later. And then you set the protocol and you connect to the server. Your server, remember, was 127.0.0.1, and you connect to it over the port 9899. And once connected, you will log on the screen this text which says connecting to 127.0.1 on port 9899. What will happen after the connection, you basically listen to the events. If a login response event has been sent, you will show whether the login was accepted or whether the login was failed. If the login was accepted, you basically send a private message to yourself, and essentially that would take care of it. Now I want to run this project for you, and I want you to take a look at this and see what happens. The first time I attempt to run this project, it is not going to work, and I will explain why, and then we'll see what we can do about this. So to run this project, you can build the project, which is already built here, and I will test the project by pressing the button test project here. As you see, the project is attempting to log on to 127.0.0.1 on port 9899, and the connection failed. And the reason was that the process failed to connect to the server. The reason for this failure of connection was the fact that I'm not having my Electro server running. So I close this project, and now next I will just run my Electro server. Remember, I installed the Electro server on the C drive under the Game Networks. I installed my Flash Developer IDE under the Flash Develop, and as you see, it's installed here. I also have the Flex SDK installed next to it, but you don't have to have it. And for the Electro server, I installed my version 4 of the Electro server under Electro server 4.0.6. Now I would run my Electro server, and I wait until the Electro server connects. Okay, now my Electro server has connected successfully. So now port 8082 is open as my connection listener to the Electro server on the host 127.0.0.1, which is my local host. Remember, when the Electro server is open, you should not close it. Just minimize the Electro server application, because you're trying to connect to this application over your port. And then let's go back to the Flash Develop, and let's run our application. Now this time the application runs. It attempts to connect to 127.0.1 on port 9899. The response it gets is that the connection was accepted. It's sending a login request. The login request is accepted, and my user as Coolman4366 is logged in. Once this is logged in as this random user, it will send a private message to myself, and the private message is received from Coolman4366, which is myself, to myself, and the message was "Hello World." Okay, now that you have seen this project at work, let's go ahead and let's download the shell of the project, which is an empty project, with all the libraries installed and the binaries installed for you, so that you could basically run the project, and then we will fill in the blanks. But next, we'll talk about your Electro server API and some terminologies that you need to know before we start working on this project. Alright, now to start writing our first example, which is Hello World, we need to see exactly what our Electro server gives us as an application programmer's interface, so that we could work with the server. Here we'll talk about, and it will say about the API for Electro server, and then what we will do is that we will write the code that would attempt to connect to the Electro server to log in and to send and log in a private chat message. Later, in the next units, we'll expand on our chat example, and we'll see what kind of data we can basically manage to send back and forth between the clients and the server. The Electro server API that we have with Electro server 4 is an ActionScript 3 API, or application programmer's interface, that can be used by multiplayer applications to connect and to communicate with the Electro server. The API is provided by an SWC file, which is a pre-compiled code that can be used during the development time. What we will do is that we will add this SWC or pre-compiled code into the binary or the library code of our project as an asset to provide user interfaces. With the files that I will have in the Blackboard on this class, you will have all of those projects essentially created, or the backbones of the projects created, and your API SWC and precompiled codes will be included in the library folder of your projects. If you wanted to start from the scratch, what you will do either in C# or ActionScript, you will create the project and then you add your API as either references in C# or as libraries into your ActionScript file. The Electro server API allows your clients to establish a connection with the server and then communicate with the server. It also basically performs some amount of automatic management of data. For example, it keeps track of which rooms you're currently in, as well as the user list in each of the rooms. There are three main types of objects that you will your API will basically allow you to coordinate and to work. Three types of messages, or rather. And it's basically done on a client-server architecture. You can send your requests, which are objects that are created by the client and then sent to the server. For example, if your client wants to log in, they send a login request into the client and then into the server, and then the server receives that request. The responses are objects that are created by the server as a result of a request and then sent back to the client. For example, when the client sends a request for login, the server receives that request, it processes the request, and it generates a login response and then sends that response back to the client. This response would basically contain information such as whether or not your login was accepted or it was not successful. Events are messages that are created essentially do not instantiate or do not necessarily start and originate from a request. For example, when you're receiving a chat message in a chat room, that can be categorized as an event. That message may have been created and generated by the same user, by another user, or even by the server itself. Most of what we will be doing in the client API is event-driven, or rather request-driven. The client creates a request object of some kind, sends it to the populates it with information, sends it to the server, and then the server takes care of that request. Now we want to start writing our hello world example, and as I said, the files for this example are created and are on the Blackboard. As I pointed out, they're under the resources section of the Blackboard, and there's a folder for all the project files, and then you can go there and find the main folder of this file. It's a compressed zip file. You download that zip file and then you uncompress it and extract it into one of your local folders. This is an ActionScript 3.0 project, and once you download that template from the website, then you can follow the steps that we will be taking to populate and create this project. in a nutshell, here's what we will be doing. We will prepare the Electro server instance. We will then connect to the Electro server over the local host 127.0.0.1 on port 9899. Then we attempt to log in with a random username, and once we're logged in, if the login was successful, then we send a private message to ourselves. Then we capture that message and log that message on the output log. First, let's go and download this project. Alright, to download this project, as I said, the project files are under the Resources tab in the Blackboard. Left-click on the Resources tab, and then it's where you installed your Electro Server 4 and Flash Develop IDE. For now, we don't do anything with the Electro Server 5 and Unity, but we go to the Gamebook programs. In the Gamebook programs, you have the Chapter 4 code for Unit 5. And when you click on Unit 5, Chapter 4 code, you will see that the hello world.zip, which is a compressed file, is placed there. And so if you click and download that file, the file will be downloaded into your machine. Go ahead and find wherever you saved the contents of that the contents of the file. And now I'll just open up my local folders. I placed the file under the programming work folder, chapter 4, and then I'll uncompress this hello world example. As a part of this hello world example, as you see, an ActionScript3 project is created. As I said, binary files, libraries, and source code are placed under their respective folder structures in here in ActionScript. And if you double click on the ActionScript project, your Flash Develop would open your ActionScript project. Open up the source tab and open all of the folders down to the main.actionscript. And as you see here, the empty backbone shell that I created for you already has a package which is basically com.gamebook.helloworld, which is where I got my ActionScript file. There are two import sections, the Flash import sections, which are basically importing libraries from your flash.display.sprite and flash.text.text files already created. The example I showed you earlier had all of the Electro server components already imported as well. We will write those as we go on. Then the main class is basically a sprite class that's extended, and we would have to create our Electro server instance, class instance. In here, there's a private message that's created based off of a text field. So it's a variable called log field. It's a text field variable. Your main function essentially is nothing but just an initialization function, and the initialization function has been created below. The initialization function is a void function. It creates a log field, and then we would attempt to fill in these sections of the code, which would essentially connect to our declare our Electro server instance, connect to the server, log in, send the login private message, and just wait. The create log field function that you see up here that the initialization function calls up is basically another void function that creates a log field variable, which is a private variable. It's a text field object. Its width is 500 pixels. Its height is 200 pixels. And it's located at 50 and 50 on the X and Y of your screen. It has a border, and the log field variable is added as a child to this window. And I also created a private log message that takes as a string an input and then appends that string into the log field message field, which is created up here. So these are the backbones. Basically, these have nothing to do with our game network. They are basically simple user interfaces that we are using based off of our Flash environment. Right. So now, in order for us to start working with our Electro server, we need to first instantiate our Electro server object, or create our Electro server object. Now, the Electro server class instance, I have already have a comment here that shows you need to define your class instance here. Let's just make an attempt to define our class instance. I'm creating a private variable, and I'm going to call this an Electro server underscore Electro server, and I want this to be an Electro server. Okay. Now the problem is that now the Electro server has already been installed, because as you see here, the Electro server API client SWC has been created here, and the classes that you see are already declared and defined in the library file that I have. So your IntelliSense would show you that you can use the com.electrotank.electroserver4.electroserver as the object that you can declare here. To make this instantiation easy, I have up here the Electro server imports. So I'll try to import the components of the Electro server API that I need to use so that I can use them much more readily and easily in my project. So first thing, you need to import com.electrotank.electroserver4.electroserver. This would add Electro server class to your object. Then I'll add the com, which is my main project here, dot electrotank.electroserver4 .entities.protocol. This will add the protocols class to my project. Next, import com.electrotank.electroserver4.messages.event.connection events. Next, we'll import com.electrotank.electroserver4.messages.event.private message events, because we are attempting to write a private message to ourselves later. Then we'll import com.electrotank.electroserver4.message.message-type. Next, we'll import com.electrotank.electroserver4.message.request.login request. It's because we want to log in. Then we import com.electrotank.electroserver4.message.request.private message request, because we need to send a private message request to the server. And finally, we'll import com.electrotank.electroserver4.message.response, because now at this point we want the server to respond to the message request, and we want this to be a login response. This step will import all of our needed tools that we need to use in our application. The next step is to go back and finish our Electro server class instances that we need to use. So we go and create a private message, a private variable, and we call this variable underscore Electro server, and we want this to be of an Electro server class. Okay, now let's just attempt to compile this project to see if this compilation runs. Now, as you see, my compilation was successful and I didn't get any errors. So we already created and prepared the instance of our Electro server, and we tried to essentially define it. The next step is to declare our instance. To declare the instance, we will go to our initialization function, as you see up here, and right after we create the log field, we would go ahead and attempt to create our Electro server object that would define up here. Now, to declare this variable, we need to declare it as a new Electro server object. This line would basically define our object, or rather declare our object. Now, as you see, I compiled my project and I ran the project, and the project is showing me an empty field, which is the login field that I created, and I didn't get any error message. So my project is doing well so far. The next step is to attempt to connect to the server. In order to connect to the server, what we will do is that we will add our event listeners to our Electro server object that we created. Let me just show you how you can do that. Once you created your Electro server object, basically by defining an object of Electro server type and then declaring it in your code, you will be able to add event listeners to your object. So my object is an Electro server. I add an event listener to my Electro server object. The event listener function has three components. The first component is the message type or the event type. The next component is the function that will be called upon the activation or the firing of this event. And the final part is basically where you would define the scope of this function. So the first component is the type of the message. So I add message type dot connection event. Then I would have to type in the string variable that will be the name of the function that will be called once this event fired. I would call this function on connection event. And finally, I would declare the scope of my object. Okay, so this on connection event function is the function that will be called once a connection event has been created. So scroll down to where I have a comment saying that event handler to create and the capture results of a login response. So actually on the connection event attempt. So at the bottom here where I say event handler used to capture the result of a connection attempt. So here what I would do is that I would create the function of on connection event. So this is a public function, and its name is on connection event. Its input is going to be a connection event input. And my function is essentially a void function. Okay, so far I created my event listener that will call the onConnection event. The only problem with this ActionScript3 file for my client code of Electroserver 4 is that the event listener that are created, the second argument of that event listener is a string, and it has to be the same as the string that you name your functions after when that you want to be called after that event has occurred. So the only difficulty is that these two names, you have to manually double check them to see that they are exactly the same names. Otherwise you will get an error. You won't not with defining as strings here, you will not have a compile time automatic checkup of your function name, so you have to do that manually. So for now, let's just leave this part as is. We created an event listener, and this event listener essentially creates an empty function, calls an empty function. Let me just compile this file and see if it compiles, and yes, it did. So the next event listener that I would create is basically an event listener that calls up a function to respond to the login. So I go to where I have my event listener, and then I add another event listener Its message type is going to be a login response. And it will call up the onLogin response function. And this function is the function that I will write up later. Okay. Now we scroll down, and where I have the comment for the event handler that handles the login responses, I would go and create a public function, and it's called as I want it to call, login response. The event is a login response, and the function is a void function. Let's compile our program, and let's add our final event listener. It is added to my Electroserver object, and my final event listener is of the type of private message event. It will call on private message event, and the scope of that event is my class. Let's go down and declare the function for it. As you see, I have a comment also that basically I need to add the function for it. It's the function handler, or the event handler function, that is used to capture private messages. So this is again a public function, and as I called it, on private message event, and its input argument is a I call it E, the variable, and it's a private message event. My function is again a void function, and then I compile my project. So far what I did is that I defined a private variable of an instance of my electroserver class. Then in my initialization function, I declared my electroserver instance as a new electroserver. Then I added 3 event listeners to it. The first event listener is a connection event. The second one is a login response. And the third one is a private message event. Upon the activation of any of these 3 events, their corresponding functions are going to be called. The first function calls onConnectionEvent function, which I declared down here. It's a public function called onConnectionEvent, and a connection event argument accepts a connection event argument. The login response event fires on login response function, and the login response function is a public function. It's a void function, and it's called onLogin response, and it accepts an argument called login response of the type of login response. And the final event listener is a private message event that fires up on private message event. And the onPrivate message event is again a public function. It's a void function, and it accepts the argument of type private message event. Now let me show you what this exactly does, and what should be happening. Before we go a little bit further to actually make this project functional, I would have to define and set the protocol of my electroserver object. So do es.set protocol. And the protocol that I want to set, I'll give it a string, and it's basically, I want it to be a binary protocol. So it's going to be protocol.binary. Okay, and finally, I'll try to attempt to connect. So I would call my electroserver object, and I create a connection. And I send a string to this connection, which is the IP address of my socket server and the port number. So the string that I will write in is going to be 127.0.0.1. That is my my socket server host, and the port is 9899, which is the port that I will be attempting to connect. Now my main function, which initializes my connection, is completely set up. A login field is generated, an electroserver instance is created and declared, 3 event listeners, 1 for connection events, 1 for event login responses, and 1 for private message events are added. The protocol of my electroserver object is binary, and it creates a connection to host 127.0.0.1 over the port 9899. And after this connection has been attempted and created, I log a string, and this string basically would say I'm trying now to attempt connect to 127.0.0.1 on port 9899. So it's basically a string. And so this log will be added, as you see down here. It's a function that gets a string and adds that string into the login field that I created here. And the login field is a new text field with the size of 500, 250, 50, 50, and its border is true. Okay, so this last function is basically a manual function that I already created here. It accepts a string and it adds it to the log field of my message. So if I compile this and I run it, you would see that this compilation runs and it's successful. And what's happening is that once my electroserver connection is created over 127.0.0.1, the connection event is fired, and my connection event at this moment is empty. It's just an empty file, an empty function. which is called the connection event down here. So nothing is happening, and then I go and I log my values, which is trying to connect to the host on port 9899. Now, what I need to do is I need to run my Electro server. So again, I need to go onto my Electro server 4.0.6, run the Electro server, and wait until it's successfully started, and then I can run my program. Once the program runs, it attempts to connect to the Electro server. Now this time the Electro server is up and running, and so you would not get that error message that I got earlier when my Electro server was not running. But nothing is happening because my connection, my login, and my send private message events are empty functions, so nothing really happens with these functions. Let's close up my project that's running, and let's go and attempt to populate our our connection event. So we're going to go to the connection event here, and then we will log on the screen a message that says whether or not the connection was accepted. And once the connection was accepted and successful, then we will basically send a login request to the server. Okay, first off, let's check to see, as you see, the argument connection event goes into the connection event handler function, and we can check that and see if E is accepted. And we will be able to basically write out our logic based on whether or not our connection was accepted. Now, I will log onto my screen connection failure, and the reason for it I'll be able to log out, which is e.getError get description. Okay, so if my message was not, if my connection was not successful, I log out on the login window that I just showed. I log the connection failed, and I show the reason for it failing, and the reason is basically I can get it from the object, my connection event object. I look at its get error and the description of its error. Okay. Now I can also log that my connection was successful if it was successful. So let's go and log in connection successful. Okay. Now let's compile our function and let's run. Now if you run, since my Electro server was up and running, as you see here, my connection was successful. So when I attempted to log, basically down here, when I create the Electro server object, I populate its event listeners, I set the protocol, and then I create the connection. A connection event is fired, and I check the acceptance status of my connection. If it's accepted, I log connection successful. If it's not, I log that the connection was not successful. Now, let me just close this function, and then let's also close the Electro server. And now let's try to run our program. As you see, the program attempts to run and to connect to 127.0.1 on port 988, and the connection failed. And the reason, as you see per my error message, the reason was that the get error description is that the reason is failed to connect, basically meaning that there was no Electro server object running. Alright, so let's go back and rerun our Electro server so that we can continue our project. Alright, now we attempted to successfully connect to our server. Let me rerun and make sure that its connection is successful. Yes, the connection is successful. Alright, so the next step after my connection is successful is to create a login request and send that login request to the server. So let's go and let's create a variable called login request, or LR, and this variable should be of type login request. And at this same time, I will also declare my variables, which will be a new login request. Now my variable login request has been created. I need to populate this variable, or this login request. So I set the username of this login request, and I call this username cool man, and then I will send the login request. So to do that, you call your send function of your Electro server object, and then you send to it, or you use the login request that you created as your login, as your send argument. So if you run your program, you see that now you have successfully connected. And so the reason was that you successfully connected, your Electro server is running, you successfully connected to your user by sending the connection or starting the connection. You have the connection event handler as a function. It's called, and it types out that connection succeeded because of the successful connection. If you attempt to rerun this program, your connection will fail if you have multiple connections with the same username. But for now, let's just forget about that multiple usernames. And then we log onto the screen that you are sending login requests. Okay, and let's rerun the program. Okay, so you connected successfully, and now you're sending the login request. Alright, once you send the login request, your server accepts that login request and attempts to log you in. If you are successfully connected or not, a login response will be essentially fired. We already added an event listener for the login response, and upon the firing of the event of login response, the onLogin response function is called. You already created the shell for the onLogin response function, which is a void public function. Now here you can populate whatever you want to do after the login response has been fired. So the first thing we want to do is that we want to check to see if the login was successful. So you get its accepted status, right? So if the login was accepted, then you would log on the screen that login accepted and logged as, and then add the name of your user. So e.getUsername. Okay, And if your login was not successful, you just log on the screen, basically show on the screen a message that login failed, and its reason was e.get eserror.get description. Okay, now let's attempt to run this program one more time. So I ran my program, and once the program was run, the ElectroServer object got created. I added 3 event listeners. The event listener for connection event calls the onConnection event. The onConnection event checks to see if the connection was accepted and shows the connection was accepted, and then creates a login request and puts in the login request as the username coolman and sends the login request to the server, and also types out on the output screen that the login request is being sent. Once the login request is sent, the server processes that and creates a login response. The login response calls the login response event handler, which is the onLogin response function here. That function checks to see if the login was successful. If the login was successful, it shows that the login is accepted and shows the username. If the login was failed, it shows that the login failed and shows the error message of the login failure. So here, if I attempt to connect with the user coolman, then my login would be successful. Let's attempt to reconnect to the server. So as you see, if I attempt to connect again to the server, so I have 2 clients trying to connect with the same username, the first client connection gets successfully accepted, sends the login request, the username was coolman, and since that's the first coolman, the login is accepted and the user is logged in. The second time, as you see here, the second client connection is successful, sends the login request with the same username, but the login fails because the username is repeated. This shows us that the ElectroServer would not allow multiple usernames to connect, or multiple multiple clients to connect with the same username. So to do this, we need to make sure that our login request will have a different username every time we try to attempt to log in. Remember, the logic for creating a login request was in the connection event function. I created a username called coolman, and every time this function is created and called, the username coolman will be sent to connect to the server. So to do that, to make sure that the username will change every time I attempt to connect, I'll just add to the name of this username just a random number. And I will create a random number, multiply it by 1000 and round it so that it would be an integer number, and I append that value into the end of the name of the user. So what's happening here, the name of the user who tries to attempt every time is coolman, followed by a random number. The random number is a 4-digit number. The math.random function creates a random number between 0 and 1. We multiply that to 10,000 to make it into a 4-digit number, and then I round that number so that it would be an integer number. Now let's try to attempt. So as I attempt, now coolman underscore 6790 is created and added and logged into the server. If I rerun the program while the first program is running, another user is created, and his name is going to be coolman underscore 4478, which is a different username. So this would ensure that every time I attempt to connect to the server, my connection is accepted, and every time I attempt to log in, I will be logged in with a different username. So now my login has been created and my user has been logged into the server. Now let's try to attempt. So here what's happening is that I populated my connection event, which creates a login request. The login request is sent and login response from the server comes back in, which calls the login response event, and that shows me that the login the user was logged in. Now, if the user was logged in successfully, I will attempt to send a private message to the user. So I create a variable called PMR, could be any name, and I want this variable to be of the type private message request. And I also declare this as a private message request. Then I will set the username of this private message. And I can add an array of names so that this message will be sent out. So for this, I'll just send this message to myself. So I would use e.get username, and then I add the message. And the message requires to be a string, so I go hello world. And then I need to send this message. To send the message, we'll do the same thing that we did with the login request. We send the message to the server. So electroserver object.send PMR. Okay, now if I compile my program, it should be compiled with no error. And when I run, trying to connect to the server 127.0.0.1 on port 9899, the connection is successful because electroserver is running. I create a login request and I send it. The login request gets processed at the electroserver. It's accepted because I have a unique username, and I'm logged at as coolman_7570. And I also send the private message. But when the private message is sent, as you see, the onPrivate message event is empty. This function is created, but nothing will really happen because the function is empty. So now what I will do is that I will go in the private message event and I'll just send this message. So in a private message event, I just log on the screen the text private message received from the argument.private.getUsername and the message is e.getMessage. Okay, let's compile this program now, and then let's run. Alright, so again, I create an electroserver object, and I instantiate it and declare it as an electroserver object. Then I attempt to connect to the server. The connection is successful because my server is running. I send a login request with a random username. The login is accepted, and I'm logged in as coolman_9951. And I send the private message, and it shows that the private message was sent from e.username. which is that, and the message text was hello world, which was the message that I sent. The text of the message hello world. Okay, so this is how you can basically write a client-side code and connect to your Electro server. Basically, the idea is to create a private Electro server object, add your event listeners to it, any type of event listener you want. In this case, we had a connection event listener, a login response event, and a private message event. Then you set your protocol. Here's binary protocol that is set. Then you create the connection. Once you create the connection, your connection event handler is called. If it's accepted, you check to see if your connection was accepted, and then you do whatever you need to do. If it's not accepted, then you just show the error message. In case the connection was accepted, we created a login request. We populated the login request by putting this username and then sending the login request into the server. The server receives the login request and processes it and creates a response. We check the response to see if it was a successful response, successful login or not. If it wasn't a successful login, we show why. And if it was a successful login, we show that it was successful. We create a private message. The private message sets the usernames, which is in this case an array of usernames, and we only have one username, so we get the username, and then we set the message as the hello world. And then we send the private message. When we send the private message event is called. And in private message event, what we essentially do is that we just log that into the screen that this username sent this message. So we could use many functions. For example, we can get the buddies here in the user name's recipient of this message. This way the private message will go to all of the buddies of this user. We haven't set those up, so that wouldn't really make any difference in this case. If you wanted to create a public message, you could basically go and create a public message. And perform your functions as you need to do. Okay, so here we have got our first programming in the Electro server. And we ran and we saw what how we could establish connections and so forth with our socket server. So with this, I would let you just go ahead and work on this project that we have just initiated. and create your electroserver object, populate its event handlers, create the functions for the event handlers, the appropriate functions, and then send the appropriate requests to your server and show your results. And then you will submit this project as a compressed folder and a compressed file into the classwork project for this unit. And then in the next unit, we'll talk about the chat functionalities, which we just attempted a little bit here in this project. Now, the next topic I want to talk about is your electroserver administration panel. Now that we have written our first code to deal with the users' connections and requests and responses, you need to know that in order to work with your electroserver, you would have to sometimes work with the administration panel. And that would allow you to configure your electroserver options that you have. Within the administration panel, you'll be able to define IP addresses, the ports on which your electroservers listens for socket connections. Also, you can add and manage your extensions, configure how many users can connect at the same time to your server, and even create language filters. To connect to your administration panel, you need to open up a internet browser and attempt to connect to your local host over the ports that you installed your electroserver. I think that we installed our electroserver on localhost 8082. I believe that we installed it on localhost 8082, and then we try to attempt to connect to it as admin. So to connect to your localhost, you would type in HTTPS, which is a secure HTTP connection, ://localhost, and the port is 8082, and you would attempt to connect to its admin panel. Remember, when we installed our electroserver, we used the default administrator, and the password is password. So on the administration panel, you will have several options. You will have general options, security options, gateways, filters, extensions, and persistent rooms. You're logged as administrator, as I just showed you. In the general section, you will be able to manage licenses, edit server settings, edit thread settings, restart your server, shut down servers, and also return to main menu. Under the security, you will be able to manage your permission sets, change your passwords, manage your web administration users, and a whole bunch of functionalities. Under the gateway, you will be able to either run your service as a standalone or not, and also connect to a gateway. Filters allow you to set up your language filters, flooding filters, and so forth. And the extension tab allows you to add extensions to your electroserver that we just talked about. And under the persistence rooms, you can create persistence rooms, which, if you remember, we talked about. The persistent rooms were the rooms that always existed regardless of how many users there were logged in. Let's take a look at the gateway menu. Under the gateway menu, you will be able to configure the addresses and ports that allow and enable socket communications between your electroserver and your clients. So if you expand the standalone application, you would see that the number of connections to register is about 100. Listeners, as set by default, are on the host name 127.0.0.1, and port 9898 listens to text, 9899 listens to binary messages, 1935 listens to RTMP, and 8989 listens to HTTP. If you need to edit these, you click on Edit Standalone, and then you will be able to edit these default settings. As you see here, you can change any essentially administration properties for your gateways. The next object I want to talk about is the extensions. The extension menus lets you install and configure any server extensions that you need to use with your Electra server. The front end here shows you the Electra server extensions that are currently installed, and also the options that you can add new ones. And in this installation here, we have not had any server level component added to our Electra server, because we just created a brand new empty connection or Electra server installation. Finally, the persistent rooms allow you to create rooms and zones that will persist while your Electra server is running. For example, you can use this to create rooms that you want to remain constant, such as, for example, lobbies or commonly or common areas in your games. Persistence rooms share the same configuration options as those that are found under creating a room using your client API. So, and they're available for your users to join in whenever they log into your system. So these are basically great tools that you can use. We'll get into these administrations a little later into the semester, but I just wanted to show you how or where what kind of things are available to you as the administrator of your Electra server socket server. So with this, I'll just close up the Unit 5, which was your introduction to your Electra server socket server. And so go ahead and download the file which has your Hello World project shell. So I will talk to you next week when we talk more about chats, and we'll dissect into the kind of things that we just started in this unit.